Hi there, my name is Grace Amondi. I'm a GS developer at ICPAC. ICPAC is IGAD's Climate Prediction and Application Center that offers climate monitoring services to 11 member states of the East Africa region. So today I'm excited to walk you through the East Africa Drought Watch, which is a system that monitors drought conditions in East Africa in near real time. It uses both satellite data and station data. So this system can be found at droughtwatch.icpac.net. Now this system is built in collaboration with the Drought Unit of the JRC of the European Commission, and it's adopted from the European Drought Observatory, adapted to the conditions in East Africa. So within the landing page or the home page, you'll be able to see the latest situation of drought based on a map and also stress levels. So the map is able to highlight the combined drought indicator showing various stress levels from the watch, warning to alert. So on the map, watch areas highlight areas that have experienced rainfall deficit. Warning areas are those areas that have experienced soil moisture deficit following rainfall deficit, while alert areas are those areas in red that have experienced vegetation stress following rainfall and soil moisture deficit. So, addition to these stress levels, we have two recovery levels of the combined drought indicator, which we shall look at in a few. On the right, we have stress levels organized from the highest alert to the lowest by country's proportion. So within the system, you'll be able to interact with the maps, as we have seen. You'll also be able to interact with graphs and compare layers and also create analysis. So we'll go to the map viewer, which is the interactive user interface for playing around with layers and making analysis. So the first layer you'll be greeted with is the combined drought indicator, and the additional two recovery levels are the partial and the full recovery of vegetation. So partial recovery of vegetation means that this area has recovered to its normal meteorological condition, and then the full recovery highlights areas that have recovered to their full meteorological and agricultural condition. So you will notice that we have the combined drought indicator based on CHAPS, and then we have another combined drought indicator that is based on the GPCC. So these are two precipitation datasets that we have been experimenting with to see what impact they will have on what is on the ground. So this combined drought indicator is computed from three layers: the standardized precipitation index, also the soil moisture anomaly, and the FAPA anomaly. So the standardized precipitation index highlights or is able to detect areas experiencing meteorological drought, while soil moisture and FAPA anomaly are able to detect areas that experience agricultural drought. So you will notice that for both the combined drought indicator and the precipitation, we have CHAPS and GPCC products. The CHAPS product is based on a resolution of 0.05 decimal degrees or 5 kilometers, and then the GPCC is of a resolution of 1 decimal degree. So within this interactive map viewer, you are able to click on a pixel and identify a value. You can also toggle between various layers, turn them on and off. You can also drag and drop them, bring one to the top, like that. Also, you can change the opacity just to enhance image interpretation. And then in addition to this, You're also able to have a look at geographic background layers that are here. And then, as mentioned earlier, we also have an opportunity to generate reports. So these reports are based on an administrative area. So to initialize a report, you will need to click on a pixel and then generate a report. So this report analyzes admin level 1 boundaries. So in this case, you have clicked on a pixel within Kilifi, and the reference date that is used is for the combined drought indicator. So now, the elements that you'll find within the analysis report, you'll be able to see maps showing the drought situation for the area that you have clicked on. Also, the population that is at risk in the affected areas. So it is split based on the categories, that is alert, warning, and watch. Also an estimate of the total population for the whole area. And then you'll see a time series for each of the indicators, that is the combined drought indicator, the SPI, the FAPA anomaly, and so on. So you're able to switch on between various classes just to investigate the ones that you necessarily need to investigate. Within the SPI, you're also able to see a map and also time series analysis graphs for the SPI. Currently, we have it at the 3rd time scale. So we are working to have the rest of the time scales available in an interactive manner. Also, you can have a map of FAPA anomaly and the time series, soil moisture anomaly as well. Also, if you'd like to download any of these time series graphs, it's just a matter of clicking on this download button, and then it should present you with a graph such as this. So we are working to have these reports downloadable, and also working to make them automated in such a manner that subscribed end users will be able to receive these reports periodically based on the area they have subscribed to. So apart from this, within the system, you'll be able to see the drought indicators, documentation of how they're generated. You can also visit our About section. You can also contact us, leave your feedback, leave a question, bug report, and so on, and we'll be more than willing to get back to you. So once again, the Drought Watch is accessible at droughtwatch.ipac.net, and we are looking forward to you interacting with the system and telling us what you think. Thank you very much.